Let's evaluate the integral of x squared divided by the square root of 9x squared plus 4. Okay, first we're going to let y equal to 3x. We'll make a regular substitution. Y squared is 9x squared. 1/9 y squared will be x squared. Also dy is 3dx, or 1/3 dy is dx. Now we're going to replace everything here in our integral. Our integral was in variable x. We'll find an equivalent integral in variable y. First of all, x squared is 1/9 y squared divided by the square root of 9x squared, that's now y squared, plus 4. And then dx is 1/3 dy. 1/9 times 1/3 is 1/27 times the integral of y squared divided by the square root of y squared plus 4 dy. We can now do trigonometric substitution. Trigonometric substitution depends on the kind of radical. Our radical looks like a radical of y squared plus a squared. We match a squared to 4. Therefore, a is 2. Whenever we have such a radical, the substitution is y equals to a times tangent theta. So in this case, our y will be 2 times tangent theta. Then dy is 2 times secant squared theta d theta. Now we want to replicate what's inside the radical, so I'm going to square both sides. Y squared is 4 times tangent squared theta, and I'm going to take y squared, add 4 to it, and that becomes 4 tangent squared theta plus 4, which is 4 times tangent squared theta plus 1, and that's 4 times secant squared theta. So let's go to the integral and replace now everything that was in variable y with variable theta. So we have 1/27 in front. We had in the numerator y squared. Y squared is 4 tangent squared theta. Inside the radical we had y squared plus 4. It is now 4 secant squared theta. And we also have dy, which is 2 times secant squared theta d theta. We want to simplify this as much as possible. We can assume the square root of secant squared is secant. So this is what we have. We have 1/27. 4 times 2 is, we have 8 tangent squared theta times secant squared theta. From the denominator, square root of 4 is 2. We can assume square root of secant squared is secant, and then d theta. So 8 divided by 2 is 4. We have 4/27 out in front, and then secant squared over secant is secant. So the integral we have left is tangent squared theta times secant theta d theta. This integral was evaluated earlier in an earlier video, but I'll go through all the steps. The key here is to replace tangent squared with secant squared theta minus 1. So instead of tangent square, we write secant square minus 1 times secant, and this gives us the following. This is 4/27 times the integral of secant cubed theta minus secant theta d theta. These two integrals you should memorize. If you don't know them, go back to an earlier videos. They're solved. You can see how they're done. But I'll just go ahead and write down what they are. The integral of secant cubed is 1/2 secant theta times the tangent of theta plus 1/2 natural log of absolute value secant theta plus tangent theta. And the integral of secant is natural log of absolute value of secant plus tangent. So simplifying this, we have 4/27 times 1/2 secant theta tangent theta minus 1/2 natural log absolute value of secant theta plus tangent theta. And we can factor out 1/2, so this is equal to 2 over 27 times secant theta tangent theta minus natural log of absolute value of secant theta plus tangent theta. So the thing we have left to do is to express this as the function of the original variable, which is x. So here's what we do. Recall what our substitution was. Our substitution was y equal to 2 times the tangent of theta. So tangent of theta is y divided by 2. I'm going to draw my right triangle. This is theta. Tangent is opposite divided by adjacent, so that's y over 2. The missing here is the hypotenuse, and that's going to be square root of y squared plus 4. So we can now express this as our answer. Our answer is 2 over 27 times secant. Secant is hypotenuse divided by adjacent, square root of y squared plus 4 divided by 2 times tangent, which is y divided by 2, plus minus natural log of absolute value of secant, that's square root of y squared plus 4 divided by 2, plus tangent, which is y divided by 2. And remember now what y was. Y was equal to 3x. So this is our solution in variable x, our integral. X squared divided by the square root of 9x squared plus 4 is now solved. It is 2 over 27 times, now remember y is 3x, so this is the square root of 9x squared plus 4 times 3x divided by 4 minus natural log of absolute value, the square root of 9x squared plus 4 divided by 2 plus 3x divided by 2, and then we can add a constant of integration out here at the very end. So that's the answer. Let me write that down one more time, and maybe we could try to simplify it by multiplying, sending in 2 over 27. The final answer of the integral x squared divided by the square root of 9x squared plus 4 is equal to 2 over 27 times 3x times the square root of 9x squared plus 4 divided by 4 minus natural log of absolute value of the square root of 9x squared plus 4 over 2 plus 3x divided by 2. So close absolute value, then close the brackets, and that is C at the